Hi everybody, welcome back. So video 12, we are going to be doing some more practice with the limiting reactants. And this practice is going to be limiting reactants. We're going to do some of the problems from homework sheet number 1. Now, for limiting reactants, and after limiting reactants, we have one more big kind of subtopic in this unit. Organization is key. Making sure you keep everything organized and making sure you can actually get all of your calculations down in one spot. So this time through, I'm going to start showing you how to organize all the parts in these really, really big problems. So again, I'm working on limiting reactants. Homework number 1. And we start off with the chemical reaction of a large Alka-Seltzer tablet. Now, our Alka-Seltzer tablet contains 2 different chemicals. So one tablet contains 2.5 grams of NaHCO3 and 1.5 grams of, bigger thing, H3C6H5O7. So one Alka-Seltzer tablet contains 2.5 grams of the sodium substance and 1.5 grams of the hydrogen substance. And it reacts with water to form NaHCO3 when combined with water as a catalyst. So we're not going to list it as part of the reaction. H3C6H5O7. It will break down into CO2 and H2O and Na3C6H5O7. Okay, so step 1, got to balance the equation. Start off with sodium, got 1 on the left and 3 on the right. I need 3 on the left, so I'm going to throw a 3 out in front here. Then we can check hydrogen. This one might be a little bit more complicated. I've got, let's see, 3 here plus 3 here is 6 plus 5 here, 11. So I've got 11 on the left. Right now I've got 5, 6, 7 on the right. Okay, so let me see, is that right? Yes, so I've got 7 on the left. If I throw a 3 out in front here, I've got 6 here plus 5 here, and now my hydrogens are balanced at 11. Now I can check my carbons. So carbon, I've got 1 plus 6, I've got 7 over here. And right now I've got, oh no, I've got 3. I've got 3 plus 6, I've got 9 over here, and I've got 7 over here. So if I throw a 3 out in here, I've got 3 plus 6, I've got 7. I've done sodiums, hydrogens, carbons. Check your oxygens. I've got 9 here plus 7 here, 16. I've got 6, 7, 8, 9, 16. So everything's balanced. Throw some 1s here. If your balanced equation isn't right, nothing else can be right. So, got an equation, got it balanced. Now, before we even get to what the problems are, we're going to assume we're going to solve every possible thing. So I want to figure out how much of each reactant is going to be used, how much of each product is going to be made, how much excess reactant is going to be left. To do all those calculations, I'm going to need a molar mass. Am I on my screen? I am. For each substance, I'm going to need to know which substance is the limiting reactant. To organize my table, I'm going to need to know what is my reaction. I'm going to need to know what are my initial amounts, so what are my starting amounts or my initial, and how much of each product am I going to make, which would be my theoretical yield. So I'm going to be doing lots of calculations, starting with filling out my reaction. NaHCO3, H3C6, H5O7, CO2, H2O, Na3C6, H5O7. Balance it. 3, 1, 3, 3, 1. Now, limiting reactant, I'm going to have to calculate. Initial, that is something I know. I know that I start my reaction, I'm going to do a lot of color coding here, with 2.5 grams of the sodium substance and 1.5 grams of that substance. Molar masses, I can calculate. I'm just going to go ahead and let you know. These come from the periodic table. Again, just kind of that ever constant reminder. But molar mass for the sodium substance is 84 grams per mole. This substance is 192 grams per mole. CO2 is 44 grams per mole. H2O is 18 grams per mole. And the sodium on the right is 258 grams per mole. So I filled in what I can. I know my molar masses. I need to calculate my limiting. I know my initial amounts. Now, I'm not going to have any initial amounts for products, so that we can go ahead and leave blank. And I don't know my theoretical yields yet. I'll have to calculate those. Step 1, start every problem by calculating the limiting reactant. So I am looking at the sodium and the hydrogen substance on the left. It's working just left to right. I'm going to start by looking at the sodium, NaHCO3. Now, I start my reaction with 2.5 grams of the NaHCO3. In order to determine my limiting, I need to go from grams to moles. I use the molar mass bridge, so 1 mole contains 84 grams. 2.5 divide 84 in a calculator, we get 0.030 moles of NaHCO3. Take that and divide by your coefficient. So take this, divide by my coefficient, which is 3. And my value here is going to be 0.0099. I'm going to take that, compare it to my other substance, which is H3C6H5O7. I start with 1.5 grams of that. Go from grams to moles. Using, again, that molar mass bridge. So this is 192. It's my pink color. 1.5 divide 192, I get a value of 0.0078 moles of H3C6H5O7. From there, I need to divide by my coefficient, so 0.0078 divided by my coefficient here is 1. I'm still going to show the step though. Any number divided by 1 is that number. Determine the smaller number. This is 0.009. This is 0.007. This is my smaller number, which makes the hydrogen substance my limiting reactant. So I can go back up top now, and I can label hydrogen substance is going to be my limiting substance. That's going to be what runs out first. That's going to be what determines how much product I can make. Now, since I know this is going to run out first, if this is going to run out at the end of the reaction, my theoretical yield, I should have 0 grams of that substance. Whatever your limiting is, you should completely run out of that substance. Now, the sodium, I'm not going to completely run out of that substance. So my next step is going to be to calculate how much of the sodium NaHCO3 is going to be left at the conclusion. That calculation would fall under the category of excess reactant. Using my value for the limiting reactant, which was the 1.5 grams, now, some people would say, oh, you calculated this, just start at the moles, it saves a step. I always start with the number in the problem because that number's right. And if I made a typo here or a miscalculation, that number may not be right. Now, some people will say starting here gives you more room for error by hitting miss buttons by doing that extra step. I don't care where you start. I'm always going to start at the front because I know that front was right. So go from grams to moles. One mole contains, use the molar mass, 192 grams. From moles of one substance to moles of another. So moles of what I'm at, the H3C6H5O7, to moles of my goal, which is to figure out the excess reactant, which is that NaHCO3. Using my coefficients, the 3 goes with the NaH. A 1 goes with the hydrogen substance, so I have a 3-to-1. And then for moles of this substance, I can go to grams of that substance. Using my molar mass that I already calculated and put way up the top, 1 mole of the sodium substance contains 84 grams. So it's going to be 84 over 1. Type that into a calculator. 1.5 divide 192 times 3 times 84. And I figure out that I am going to consume 1.97 grams of NaHCO3 consumed or used. Now, I want you to notice if I'm consuming 1.97 grams and I started with 2.5, to figure out what is left, take your initial minus my consumed equals your remaining. My initial, I started the reaction with 2.5 grams. I've consumed this 1.96, 2.5 minus 1.97. I am going to remain or have an excess of 0.53 grams at the conclusion. Now, put it in your table. How much of the sodium substance am I going to have left? I'm going to have 0.53 grams left. At the end. Now, what I would like you to do is calculate the other three. So how much CO2 are you going to have how much CO2 can we produce? How much H2O can we produce? How much of the sodium substance in the product can we produce? Just make sure you start with the 1.5 grams of the H3C6, since that's our limiting. But I want you to go through and finish the table and calculate how much product in grams can we theoretically produce for this reaction.